I will install this.
All right. So
Who will introduce everything? You will introduce?
Yeah,
or
I'm introducing.
you? All right. So
yeah.
I give you this,
Yeah.
like that, yeah, and then we switch on our
Okay.
speaker, yeah.
So I'll just and that's it on just now. Hiya, just get started, everybody. Welcome, everybody, to Scotland Data Science and Technology. Great to see everybody, as always. We've got a really good evening ahead of us. And again, it's great. So I've been probably running this group for probably over 18 months now. And it's great to see so many people coming along. And tonight we've got along to present who've attended the meetups kind of from the start and supported us on this, so it's great to see as well. We've got Yuri, a data scientist from Iridia, really looking forward to listening to him present, and Mike Chandler from Heriot Watt, Professor in Computer Science. Should be a good presentation as well. So welcome everybody. It's after the kind of data fest, it's been a kind of massive time for Scotland within like data. There's been quite a lot on. I know if everybody, I don't know if people were there and involved in some aspects of Data Fest. It was probably put Scotland on the map for data. The calibre of the speakers and the people who attended. So that was really great. And again, just a quick mention that MBN have been working on a project in Scotland. It's one I'm really kind of proud of myself. We've been working on a project with the Data Lab. The Data Lab have funded a number of MSc students in Scotland, and by next week we'd have placed every single student who were looking for a placement. So that's from like Dundee, Stirling, Aberdeen, Glasgow. There's been probably over there was 90 students, but around over 50 were looking for a placement. So we'll probably have put 50 MSc students into industry for the 3-month placement, which I think I'm pretty proud of myself. And it's kind of this is the initiative that's going to really get the industry growing. If half of them get a full-time job this year and moving forward. I know Neil's he's sitting here tonight. He's from Stirling. He went for his interview for a 3-month placement, and it was that good. He was offered a permanent job on the spot. So he's going to do his with Virgin Money. So well done, Neil. Anyway, so again, so that's well done. So he'll go along. He'll do his 3-month placement, and he's got a permanent job, which is great. And that's what the kind of meetups and that what everybody is doing here and the community is all about. So it's great to see. But with that, I welcome Yuri to the stage. And looking forward to listening to you.
Use that. Just hold it. See that? Okay. So hello everyone, and it's my pleasure to be here and actually for the first time speaking here at the meetups. I've been here, as Michael mentioned, before, and very excited. So today I will talk about what can data scientists learn from DevOps, and I'll begin with a little blurb about myself. So my name is Yuri. And I work as a data science consultant at Iridia, and at Iridia we support healthcare informatics, and we support healthcare researchers to collaborate across institutional and geographical borders by provisioning cloud-based analytical platform. So that's what we do. And briefly, I'm going to map out what I'm going to talk about tonight. And so first thing will be is like who are data scientists today and where in business in general, and then some challenges associated with that, as well as I will move on to what is DevOps in nutshell, essentially, and then a little bit on like how to, some tools we can use, some automation techniques, and which we can use in our data science work, essentially, to improve the stuff we do, to reduce amounts of time spent on various repeatable tasks. Also, I'll briefly talk about some ideas and general about conceptual things about how this flows into various. I'll begin with a little blurb about applications and industries. So in our case, it's healthcare research, but I'm sure I work as a data science consultant. People will see this patterns might benefit as well in other industries. We support healthcare informatics and support health. And then, as a wrap up, just to see general, like how can to collaborate agile methodologies and DevOps practices and when they're linked up with data science, how can they improve cloud-based analytical platform? So that's what we do. And briefly, I'm going to map out what I'm going to talk about tonight. And so this question has been asked hundreds of times. Like on my LinkedIn daily, I get like 3 articles about what are data scientists, what are them, and some challenges associated and things like that. So as well as I will move on. Who are data scientists? It's quite an open question because data scientists do a lot of stuff. So it's not necessarily tools we can use, building models and automation. Sometimes data scientists are even involved in sales. Sometimes people say that data scientists are supposed to understand business, and then so it's a lot of things to take to do for data scientists. So that's why it's quite difficult to define precisely what data scientists are meant to do and what they're doing, and that's why these articles are always circulating around. But it's understandable. The reason for that is it's quite a lot asked from us, data scientists, to do. If I think about in terms of skill sets, so we have to be computer scientists. So we have to like have, I don't know, understanding cloud computing, security, telecommunications even, analytics, obviously, so statistics, data analysis, machine learning, now deep learning, and all those things, and then data management. So we were meant to be able to interact with databases, bring data across borders, combine it, aggregate it, all those kind of things, as well as complex things like making data coming in real time and be analyzed and automate everything. So. But also, we often ask to be entrepreneurial, to have domain knowledge. So if you're a data scientist in finance, you have to know finance. If you're a data scientist in healthcare, you must know healthcare, etc. And in general, you must understand how business works. You must be able to, people bring data scientists into meetings and say, okay, data scientists say that you should do this. And they're like, yeah, we should do this. So it's a business and entrepreneurship as well. And of course, like my favorite bit is art and design. So it's not about bringing together, building stuff. It's also making it pretty in a way, so like dashboards, etc. And that's where the multitude of tasks come into play. So you ask data scientists to build beautiful, fancy dashboards, send them to Forbes journals, whatever, or build, AI robots and machine learning algorithms who will automate things. So a lot of stuff, and the skill sets are required for that as well are quite broad. So in a sense, what I ask the question is, so if it's so hard to define what data scientists are, so what if we call them like analytical software developers or something like that? Because in essence, what we do is we're managing user requirements, whether it's for a client or internally or whatever. So we know that we have to do this, and that. So software developers doing similar things. So also we're managing the environment. So if I'm using open source packages, so Python or R or whatever, so I want to make sure that they work, that I know what they're doing essentially, and that they can run in various environments, whether it's this version of Linux blocks or this version of Linux blocks, and how do I make sure that it runs for someone else as well. we obviously write code. So, we have to test it and we have to deploy it in some way or form. But what's often missing for data scientists in terms of skill sets is software development life cycle. Why software developers are very familiar with software development life cycle methods, and then data scientists are often not. And this would be my question to you guys, like to an audience. Can somebody say, like, why is that? Why data scientists often don't have this culture of software development life cycle? Any ideas? Perfect. Yeah, spot on. Very often, data science come from non-computer science or software engineering backgrounds. So that's true, which is a good thing because domain knowledge and all that, you have to have that. But there are various routes for people becoming data scientists, whether you market who upskilled and became data scientists, or loads of PhD students from physics, maths, or any other disciplines like becoming data scientists, including myself. My background is first place is in criminology. So, and then you train yourself up to become data scientist. But software engineering and software development life cycle is often missing. It's not part of a culture because you can learn Python, you can learn, because that's what you want to learn. In first place, you want to build pretty charts, do some machine learning, learn manipulating databases and all that. You say, I'm a data scientist now, but this is a fundamental thing, and it's very often missing. Not in all cases, but often not there. And this kind of leads to some cultural problems. So in the first place, data scientists, but without having this culture, they end up working in silos. It's like, oh, I know how to do this model. I'm having this task to do for my manager or for my client. And you take your laptop and you start prototyping and you're playing and try different packages, different algorithms. So, but then it creates this problem of it works on my machine. So, and isolates you from the rest of the team. So it's important to collaborate. It's important to work in a wider team. But this lack of this software development lifecycle culture leads to working in silos, as well as the environmental setups. So, if you work and you have your laptop and you want to find a new package from Python, which is open source, you plug it in and it works, it's fantastic, you're very happy, but will it work for my colleague on other machine or etc.? So this creates a lot of problems as well. And things like very, very simple. So if I specify specifically which version of the package to use, that's fantastic and it works. But then, is it secure still in 6 months? Is it still secure in a year? And the same problem happens if I constantly keep just taking the newest version. How am I making sure that my environment and my solution works? The next thing is obviously unreliable code. If you work alone and people don't review your code regularly, if you don't have this element of collaboration, your code becomes unreliable. Even if you're a great coder still, you can make a bad code design decisions very early on, continue on with your work, and then it just becomes too late to change something. So having no code reviews and culture like that helps you to spot like errors way earlier in the life cycle of your solution. And reproducibility, and in our space in healthcare, reproducibility is extremely important because we all hear in the news that there is a crisis of reproducibility in research, and essentially, again, if I work alone in my own environment, with my own packages, with my own styles, how easy it is for someone and test my model, see if it's valuable, if it's valid in general. So these are like some of the problems which can come from data scientists not necessarily sharing this culture. And then moving on, so what is DevOps? In extreme nutshell, some of you will know, some of you will use DevOps in some way or form. But as I said, for many data scientists who come from non-data science background, those things might be, they have to upskill themselves. They have to learn on the go. And so DevOps in general is this combination between operations teams who develop software, who not develop software, but who develop infrastructure for your software to be serviced to the clients, It's development teams who essentially develop new features and make your product what it is, and QA as well. So and for QA is basically quality assurance and testers. So combining all those teams and aligning them into some specific, in the same direction, that's what DevOps is about. It's not about what tools you use. It's not about anything like that. It's about this culture of organization in general. And traditionally, this came from the development and QA. So they want agile. They want to deploy new features very fast. And because your next feature might depend on your previous feature, so you want to ship new software, you want to create amazing stuff, where operations, on the other hand, have completely different motivation. What they want the software, the service to be error-prone, to be stable, never to go offline. That's their job. But if you think conceptually, the operations and developers, right? So they have a different motivation. So they're not aligned. And traditionally, so those teams were kind of separate, and they were unhappy with each other because, developers don't get their features implemented as fast because there are roadblocks, and operations constantly bothered with breaking stuff. So there's traditionally very different motivations. And that was obviously a problem. So the DevOps culture emerged. So in terms of theory and essentially, and as I mentioned, it's not about tools you use. It's not about the automation techniques you choose. It's not about who has access rights to what modules and data, etc. It's not even about teams themselves. It's all about kind of communication, understanding, and integration and alignment. So how easy it is to integrate different teams, work on the same user stories, work on the same features of the project, etc. How do you align them so there's no this intrinsic conflict? So this is DevOps as a culture in a nutshell. There's way more to that, but in general, it's instead of having the teams pulling in different directions, aligning them conceptually into some cycle when they work together. So it's regular meetings, it's regular stand-ups, it's a discussion on ways how to do things together, not separate, but together. And then this creates this DevOps cycle. And currently, in terms of software development, I guess, these methods are very obvious. This is proven to work way better. Removes the roadblocks. Everybody is way more happier. So it's there. And that's how now software is being developed, and it's faster, it's more reliable. But if you Google DevOps, that's kind of the standard way of working right now. The problem is, where is data science in this model? Because as I said, we do similar things with developers. We write code, we write models, we have to deploy them in some way or form. But we are not in this model. We are isolated. We are like in our own kingdom there somewhere. So how do we bring data science into this? Because it's very important. So what I propose, and what from my own experience, my journey as a data scientist, because I kind of not from software engineering background, I had to learn these things on the go. And when I started introducing these things into my work, I noticed significant improvement. But the reason for that is probably we have to move from DevOps only to some form of, I don't know, call it data ops, because there are reasons for that. So first reason is we work in multidisciplinary teams. So across various organizations, you will see that you end up working with people with very different skill sets and very different roles in the team, whether it's business, there's software developers. So currently, software developers come and ask me, hey, we deployed some new analytical stuff on our platform. Can I go and test it on our development environment? And I was like, yeah, fair enough. So traditionally, I have to go and spend hours setting up the environment, getting of OS, of Linux, etc., setting up packages. It all crashes, it doesn't work. I spend hours doing that. But if having some form of DevOps model, when you can automate processes, you can just package stuff up, give it to other team member or person from other team, I can go run, do my tests, made my report, this is it, sent, it's done. So, or if we have hundreds of environments, hundreds of workspaces, for example, used across the globe, and sales team or marketing team are doing some big demo somewhere in US, I don't know. How do I make sure that it's easy for them to be confident that this demo will run, that they can get the artifacts, that they can get the newest version of stuff, and it will run? Do I go and tell them, hey, you salesperson, go install right version of Linux, go install right version of packages, manage all the bugs as you go, and so? No, I rather set up some form of agile process, some form of CI to pre-package all things, to automatically test them, and then just tell them, this is the process you follow, you get the right artifact, this is how you deploy it, it's all documented, it does work. And it's tested beforehand, so we have confidence it should work. So that's, for them, it's a very different experience. And across teams right now, whether it's developers working with data scientists working with sales or marketing, doesn't matter, but the boundaries, they disappear. The next issue with this is the data becomes very complex. So one thing is having data which depends on other data, which depends on other data, which is cross-referenced against various ontologies. In healthcare, that's a common issue. And how do you make sure that the data you build your app for or on is reliable and accurate? Also things like when data has to be always like almost real time or up to date, just getting the data right becomes its own solution, its own challenge. So data is complex as well. And of course, solutions themselves. So if you think about it, data science is way beyond just here's my CSV, go and do some stats on it. Data science now, it's about deep learning, it's about building complex solutions, which you often involve large team collaborations. And so I think just doing that, and now the algorithms themselves become a product which is sold on the market. So because of this, the change of culture to DevOps-like within data science is very important. Of course, accuracy becomes like a next issue, which is very important. We have to trust our data. We have to trust that what we do is essentially correct and relevant. So now a little bit on how-to and tools. So first of all, what I want to say is that no a set way of how things should be, essentially. It's really up to you and your team of deciding on processes, trying it. It's not like a one-night solution. You really have to evolve with this process. You have to evolve your own processes to do that. But first thing, which is really helpful, is having some sort of user requirements tracking way of it. It can be Taiga, can be Jira, can be whatever, but essentially, even Notepad if you want. But some way for your teams to isolate the project into, like, think it as a if a new person comes into your team, you say, this is the project ID, and this is how you find all the stories. This is how you find issues. This is how you find all the user stories and features which we need to build for this project, and basically the timings as well. So this is very important, where this kind of knowledge and approaching the project becomes a shared between teams. So the next bit is, of course, the most important one, perhaps, is the version control systems. So I bet most of you will use some form of version control, but as simple as managing your source code and collaborating on your source code, and essentially code reviews. That's what's very important. As I mentioned previously, if you review your code, you encourage to write a code better, you encourage more robustly, and as well, it helps to spot like problems, errors, and some design issues very early on. So if you say, oh, this is how I always did my apps, and someone comes and says, look, this is way better you can modularize this app, you can reuse this function twice, etc. So the general design of the apps becomes way better from the very early on, because the code is reviewed in the first place. So this is very important. And of course, the next level is some kind of continuous integration or deploying. That's where you automate things, and And in this example, for example, like if I need to, if developers want to bring me to test something, they can package up using Docker or whatever, some ready artifacts for me to come do my testing. This saves so much of my time. Or me packaging up various projects, automatically deploying them on some test machine. So, and then where the sales or marketing people can just easily use the artifact which has been tested, instead of me having to email them or I don't know, whatever, ship them each artifact. Or things like, imagine when you have hundreds, you have two people data science team, and you have hundreds of artifacts and projects. And then a package got upgraded and things started failing. How do you ship this fix to every artifact used on various environments? So some kind of automation, continuous integration is very helpful and just makes things way better as well. So and then communications. So things like Slack is fantastic for communications because you can integrate it with all those previously described services. So this gives you like one top view of what's going on in your organization and on who works on which projects, what needs to be done, what are the issues. This all gets funneled down into like something like Slack. I'm sure there are other tools as well, but Slack is fantastic. And where you can set reminders and communicate and chat. So a typical example of such workflow would be start working on a new project for a client somewhere. And first I meet with my team and with maybe members of other team, and we discuss what needs to be done, what are the user stories essentially. And what we do is we use something like Type, where we put our user stories and assign them who's working on what and some timescales. So then everybody knows what they have to do. As well, this project becomes isolated in terms of its context. So if I want to bring someone else from outside, I say, this is the project, and these are all the services which are associated with this project. It's kind of like an object. It becomes way easier because you can just easily integrate with that project and do your work. So next thing, we do our changes. So for each user story, we create our changes, we push them into some kind of repository, and we review the code so it becomes better, and we make better design decisions early on. And later on, once this is ready, we set up an automation on something like TeamCity and deploying into our test workspace or test virtual machine or whatever. When it's deployed, and then we can set automatic tests and can do it nightly. So if something fails or something gets updated, our team gets notified immediately, and we can go and do that. That's otherwise in data science. Usually, you just do your stuff. Someone else comes, commits something, and it breaks. So this is a way better approach. And then all these team members are communicating with something like Slack. There's another missing ingredient here, and it's documentation. So what's important here is have some sort of wiki, to document these processes. So essentially, how things are done in your team or your company. This helps with, so it's not as useful as only one team has their own processes, how they do things, and then some other team has the other one. So what's important is when your whole organization follows the same processes around these issues, and then everybody just starts speaking the same language. And it just becomes easier to integrate people from other teams. It creates way better alignment. And so this is like a general overview of how things can potentially be done. And this works if whether you're working alone on a project or whether you have a team working on a project. It also, and in the context of healthcare, where in the space where we are, so there's always this motivation and encouragement for kind of fair data principles, which is findable, accessible, interoperable, and reproducible, because we want to have confidence in our data and in our findings. So especially when it's healthcare. So what's important is that maybe we can do better. Maybe it's time for data scientists or analysts or people like that to upskill themselves if they lack those skills and see what we can do better. How can we bring reproducibility, stability to the stuff we develop and in the projects in wider context. Because it's if you can prove that your code is robust, your solution is robust, it's not going to fail. There is whole system on infrastructure which supports your project. It's easier to get things like funding and grants for your project, and just makes things reproducible and generally it just increase the quality of the stuff you build. So some takeaways from all that. Essentially, it's like organizational benefits. So we can track and manage user requirements better. So we know what needs to be done. We know how it's to be done. We can plug in discussion to our user stories. And in this way, we can come up with better ways of doing things. Prevents teams from isolating from each other, but as well individuals. You always on Slack, you always communicate, you know who's doing what, you exchange ideas, you have discussions all the time, you collaborate on code. It just makes it more fun, to be honest. So, and it really prevents people from locking themselves up, working on their laptop alone. As I mentioned, team alignment in general. So when it's easier to plug in other people from other teams on the same projects, we're all in the same boat in the end in the organization. So this kind of shared language or shared processes, they create this alignment with the teams. And I've noticed this in my experience quite a lot. Also, of course, better quality of your code and solutions early on. And code becomes more reusable. So using these kind of approaches like TeamCity, CI, continuous integration. So if I don't have to rewrite my code hundreds of times, I can package my code into some package. So this function does this. Let's say I want orange, yellow, and I don't know, blue histograms. And they're all different for whatever reasons. I can create artifacts for these histograms, which will be automatically tested, let's say, weekly. And then if I create a new project which needs this functionality, I can just manage my dependencies. I can set up all these dependencies. And then when I ship my project for some kind of delivery, whether it's development team or marketing demo, whatever, this project will automatically create an artifact for me, which will include the dependencies I mentioned earlier. So I don't need to go and copy paste my code across hundreds of projects. I can literally use these as constructors or sort of speaking microservices. Maybe we'll have to start moving towards this, just like we started moving towards microservices increasingly. Maybe it's for us in terms of data science time as well to consider doing things better and more modularized instead of having one large solution. And also documentation and documenting these processes creates this shared culture in general and improves quality. So these are some of the organizational benefits. I'm sure there are more, but some ones I kind of thought. And then just to wrap up right now, but what I talked briefly. So this is my experience. This is what I had to learn as I went as a data journey. So and the way it happened is at some point I was accidentally collaborating with dev team and was invited to their Slack channel, where I saw all these integrations, all this cool stuff, all these cool tools, and I thought, how can we utilize methods like that into our data science work as well? So briefly, just to kind of summarize what we talked today about here, is we discussed what a data scientist today. So that it's not some particular answer, that because in some organizations, scientists will be focusing on building very pretty histograms, very pretty charts and dashboards. In some other organization, they will be working on complex deep learning solution, building robots, things like that. So, and some other, they will be really informing markets and informing business decisions. Really depends, it's a wide spectrum of what data scientists are and what they can do. Also, we kind of discussed in a nutshell what DevOps is and why DevOps is used in development lifecycle of software. And we talked about perhaps we need some form of data ops as well, of somehow integrating data science into these like DevOps like methodologies. And then in general, how this can help us to do better data science in the first place, to create better solutions and more accurate solutions and more robust solutions. How can we make it easier for everyone outside of data science teams to integrate with what we do? And then avoiding repeated tasks. Like you've all seen this graph before, perhaps. Like everybody knows that 80% of time data scientists spend on cleaning data. That's a lie. The truth is that yes, we spend about 10% of our time on visualizing it, and it's true that we spend about 10% of time essentially. Yeah. So, and 80% of time, it doesn't just include cleaning data. It's really oversimplification. It includes everything. It includes setting up packages and environments. It includes linking data up and many multitude of tasks along just cleaning data. So think about it. What if we can automate proportions, make them simpler using something like DevOps methodologies? What if we can, if we have to, update our data regularly? What if we can create a job or an automation which will do it for us? And then what if we can integrate that automatically into our workflows? And how much time out of these 80% we can actually save? I think there's a lot of potential in there. And I think that's me. So yeah, just want to say thank you for you guys listening. Hope it was useful. Also want to say thank you to my colleagues at Aridia. It's been lots of encouragement. It was great working with you on all this stuff. We're pioneering a lot of this learning in our own time, and it's just been quite great and enjoyable as well. Also some of my friends outside data science and Aridia, lots of encouragement from you guys. And I really want to say thanks to you guys at MBN and Data Lab for organizing things like this, because I've been coming to these events for quite some time, and it's been always useful for learning new things in the first place, as well as networking, obviously. So it's been great effort, and you have to come here and stay till late and do all this stuff. It's hard work, but I appreciate that. It's really good. So I think that's it. Oh, and small announcement. There is a data science Edinburgh Slack channel. It's been there for months. It's very quiet, so nobody does anything there. Nobody talks. I was invited some time ago, but there's like no big communication or anything. So I think it would be great if some people who are interested in data science work or just if you're experienced gurus of data science, maybe you can share your knowledge. If you're newbies, you can ask questions, pick up and discuss stuff, share resources, and also what we have an ambition to have like Edinburgh Kaggle team to basically participate in competitions and have joint submissions. So so this is the link. I think what I'll try to do, if my other laptop works, I will maybe leave it open next to pizza. So if you come and grab a slice, you can type in your email, and then we'll just send an invite, and there will be more people in the group, and we'll see how it goes. Yeah?
About the Edinburgh Kaggle team, will you have GPUs or some kind of computational resources that, because this is...
If you have a GPU, bring it over. We'll use it.
That's what I don't have. The thing is, I think these problems are interesting, but you need, like, Kaggle, over time, the data sets get bigger and bigger.
Yeah.
Like maybe 5 years ago or 4 years ago, you can use your laptop. Today, the data sets are so big, you just, forget it.
You can buy a GPU and plug it in. Like,
people in Edinburgh look at doing a Kaggle. There's lots of companies who would support it, like Aridia, Deloitte, and like so there's loads of. But if people are, I was looking at it as well. I got an email the other week about Kaggle, and it was enter a competition and put a team forward, and there's people in it.
it's just more fun when there's more people.
There's companies with platforms and facilities to, if there's a good team there and they're willing to do it, the data lab, I'm sure, could probably help facilitate it as well. There's all the people there as well, so no, interesting.
Yes, I just think it would be great to bring more people on board and discuss and see how it goes, really. So, and yeah, I'm sure there'll be some support as well if needed. We can. So yeah. So this is generally kind of my insights into what I learned in last year or two doing data science work, and coming from non-computer science or software engineering background, how learning about these things really improved the way I do my stuff, and really definitely improved the quality, and just became more enjoyable as well. So does anyone have any like immediate questions, or we can just let Mike speak? Oh, okay, we have.
Not really a question, just I really like the presentation we have done. I'm a backend software developer, not a scientist. I can give some more input for user requirements. Try to see example mapping.
Okay.
It will help you very much to gather requirements, and then you can write them in certain language if you want.
It's fantastic.